Hello, my name is Thomas Langer. I am Helidon architect and I will show you a demo of our DbClient. This feature is available since version 2, milestone 2. We have published our documentation. I will post the link in the comments under this video. I have started with our quick start example. So if you go to guides and copy the quick start example, you can create the same project I will be using for this demo. Now I have opened this project in IDE and I will guide you through the things that need to be done to use the DbClient. We will start with the dependencies. So there is a section that I have added to this example, which are these three dependencies. We have the DbClient API itself, we have JDBC integration for the DbClient, and we have a database. In this case, I will be using an H2 database that I have locally running in a Docker. The JDBC is one of two implementations that we support currently in Helidon. The second one is reactive Mongo driver. The DbClient is a reactive implementation with non-blocking access. Obviously for JDBC we needed to resolve this. We have used an executor service to rob the JDBC client. Why would you do that? So first thing is you cannot block threads when running in a non-blocking reactive implementation such as our web server. Second, there are a lot of drivers available for JDBC, so there are a lot of databases that you wouldn't be able to use without such a workaround. And third, Helidon DbClient adds all the known Helidon features to it, so if you use the DbClient you will be able to have tracing propagated to your database. You will be able to get metrics from the database statements, and obviously you will have all the nice features that you already know from Helidon. So the first step, as I said, is our dependency. Second step is we need to configure our DbClient so it can connect to the database. So in my application.yaml, I have created a section called db. I tell it we will be using the JDBC source. We do have an explicit choice here because you may use multiple drivers in the same JVM. In the connection section, I configure the URL. As you can see, this is a standard JDBC URL, the username and password for my H2 database. And then I have created three statements. I have the create table statement that we will use at the beginning to set up our database. I have the insert statement to create new values in the database, and I have a select statement to get a value for one name. So this is needed, otherwise we would not be able to connect to the database, and the statements are needed because we think it's simpler to configure the statements in the language of your database and at the same time to have them outside of the source code. You could obviously use inline statements when invoking the database, but then if you decide to choose a different database, you may need to go back and rewrite your source code and recompile it. With our approach, you can have H2 database in your development environment and then, for example, Oracle database in your production environment, and you can just change the SQL statements in your configuration and everything will work as expected. Now we have two choices that are visible here in the example, and that's about how parameters are invoked when calling the statements. So you can see here we use the question mark, which is the standard for JDBC, where you send in ordered parameters and based on the order the question marks are filled in. Second approach that we have in Helidon is a column-based named approach for JDBC, where each column and a name is bound to a named parameter that comes in. So let's see how we use it in Helidon. So first, in our main class, I have created the part to create the table. So let's see at this method, I'm sending the configuration as a parameter. I create a DbClient from the configuration. As you can see, this DB string has to be the one we configured in our application.yaml. And then I tell my client to execute a create table statement. So there is a create table statement in the YAML, and that will be executed. In this case, I will be doing the toCompleteTableFuture.get because this cannot be reactive. We want to wait until the tables are created before we start the server. Now for the true reactive implementation, we will look at our greet service, where I did a few things. So first thing I did in the constructor, I have created a new instance of DbClient. This will be shared by all the requests coming to this service. Second, I have created a new routing, and in this case it's the /greet/name with method put that will update the greeting in database. And then I have implemented the get and put message handlers to use the database. So as we can see here, in the get message handler, I will request the name from the database using our statement called select1, which uses the ordered parameters. As a first parameter, I send the name, and then if it's present, I will send it in the response. If it's not present, I will send a 404 saying this was not found. The second one I have done is the update greeting in database. Again, we get the name from the path, and then I get the content as a string, so whatever is sent in the entity of the request, I will read, and then I will insert it into the database using the named parameters. So here you can see I'm sending the two named parameters, name and value. So let's see how this works. I will start my application. And now I can use curl requests to get the values. I've already prepared a value for the username John. And now I will use my name, Thomas, which should return a 404 because I never created a record for me. So now I will do a put request. I will send my surname here, and let's just do the localhost 8080, and we have the greet and /Thomas. So this will insert the statement into the database, and now when I recall the original, I should get my name echoed back at me. So you can see we have inserted the value in the database, we have read it from the database, and in both cases we have done it in a reactive manner, waiting until each step executes before we did the next one. So here we can see that we do execute, insert, which returns a completion stage. Then once the completion stage finishes, we actually send the response status, and in case there is an exception, we send the error. The same thing for the select. We execute named get. Get is something specific to DbClient that is like a query, but it only accepts 0 to 1 possible results in the result set. If it's present, I will send the response. Again, this is in then accept section of the completion stage of the select. So this was a very quick guide on how our DbClient works for a JDBC driver. Thank you for your attention, and I hope you enjoy Helidon. Goodbye.